This is a problem from the quiz where we're going to look at a decomposition and then try to solve for a matrix algebra equation using an LU decomposition. So we have an A, this is your A, and then times a vector X is equal to B, and this is your B, and I just transcribe that information into this equation. Now what they want us to do is they want us to take the LU decomposition and replace our A matrix by that. And so this is what we have. Now based on what we have, let's see, copy and paste this. Based on what we have, what they're asking us to do is to leave the lower diagonal matrix L and then replace this with a vector Y. By the way, one more note here before we go on. We should note that this X vector is really a 3 vector, because if you look at this multiplication over here, we have 3 columns, so we need to have 3 rows in that case. So what we're going to do is we're going to replace this with a vector Y, and we have to again carefully look at how the vector Y should look like. The vector Y should have 4 components. So I'm going to go ahead and make a copy of this down below. Let's try that again. Make a copy of this, set it down below, and then we're going to set this equal to our Y. Let's see if I can find my Y vector. So this is going to be your Y vector, which means this is supposed to equal to your Y vector, whatever your Y vector is going to be. And so our task here, our first step, is to solve for this, and because our matrix is already in a diagonal form, it should be easy to solve for, and they call this forward substitution, where we start with the top row. You have a Y1, and that's equal to Y1 plus 0 plus 0 plus 0, that's the product over here, is equal to the top element over here, which is 160. So already you found one solution. For the next row, if we do the row and column multiplication here, the dot product, we're going to get Y1 plus Y2, and that's supposed to equal to 20. And so we know that Y1 is 160. So if Y1 is 160, then we subtract the 160 from 20 with a negative. I think that's going to be negative 140. So that's what our Y2 is going to equal to. And then we continue on. We have Y1 plus our element here is a 2, Y2 plus a Y3. And then this is supposed to equal to negative 40 according to our B value. So we can go ahead and solve for this, and I think this will turn out to be 80. And then we can also find our Y4. So we have a 0 times Y1, so that's not going to factor into anything. We have a negative Y2 times 1. Minus 1 times Y3, and then a plus Y4, and then this is supposed to equal to 60. So if you do the computations, the calculations, you're going to get this thing to equal to 0. Alright, so now that we know our Y vector, it's going to be 160, negative 140, 80, and 0, we can replace this vector with those values that we just got. So 160, negative 140, value 80, and then get 0 for that last one. And so now we have another simple equation to deal with. Working with back substitution, first one thing to note is that we have a 0 here and a 0 row down in the bottom, so that's good. We don't need to worry about that. And then go into our back substitution. We're going to start off with this third row and this column matrix. So that's a 0 times x1, 0 times x2, and then you get your x3, make that 2x3. And that's supposed to equal to 80. So let's divide both sides, and I think we're going to get 40 for that one. And so we just continue on with this back substitution. We have a negative 0 times x1. We have minus x2. And then another minus x3. And this, according to this formula, is supposed to equal to negative 140. And since we know that x3 is equal to 40, we can add that to both sides, and then we're going to get x2, should get x2 to be positive 100. And then finally you have x1 times 1 and x2 times 1, and there's no x3s to account for because this is 0. We want this whole thing to equal to 160. We know what x2 is. x2 is 100, and so if we subtract that out, we're going to get x1 to equal to 60. And so that becomes our solution. Let's see. So we can say our solution is going to equal to, we went backwards this time, so the first one is down below, and then we got 100, and then we have 40, and then this is your final solution. Alright, I hope that helped.